Hello, everyone, and welcome back. I am Mr. Dean Cobalt, and today we are going to be going over accuracy and precision. So, these are two words that are commonly used, and in normal everyday speak, we tend to use them interchangeably, but they actually mean two very different things, especially in science classes. So, we're going to go over what accuracy and precision are, and I've got some graphs to help you understand them better. Okay, so first the definitions of accuracy and precision. Accuracy is how close your measured value is to the actual value. So when you measure the mass of something or the volume of something, that measure how when you compare that measure to how close it is to the actual measure, which you will probably look up in, say, some sort of chemical handbook, the CRC handbook, or some Merck index or something like that. You look it up, and your value, as the closeness of your value to that true value, is going to be what we call accuracy. And I don't know why I use square quotes there. Um, Force of habit, I guess. Um, so that's accuracy. So if you're close to the actual value, you're accurate. If you're far, you're inaccurate. Precision, however, has to do with the how close your measured values are to each other. So if you take various measurements of, say, the same thing, or different people take measurements of the same thing. So if I want to find the mass of, say, an M&M, average mass of an M&M in a bag of M&Ms, right? And then several different people find that average, and we compare our answers to what we got to each other. And if they're really close to each other, then that would be precise. If we're using, say, the same tool, if you will. So when we're comparing a series of measurements to each other, if those measurements are close to each other, then there is precision in the data. If they're very far apart from each other, then there is imprecision in the data. So, or another way to put it is the data is either reproducible or not. Okay, so I got a couple sets of graphs to use. First one is an analogy. It's a very popular analogy, and I think it goes a long way to help clarify or visualize what accuracy and precision are. So if I bring this down just a little bit so you can see. Okay, so here I have four bullseyes, and the red dots represent the data, right? So if I have data points that are, you'll notice that they're fairly far apart. So this would represent imprecision in the data because they're far apart. Not only would the data be imprecise, but the individual um, data points are also far from the actual point, which is represented by the bullseye. So this would be not accurate or precise. So whatever instrument is being used in this case, it would be an imprecise and inaccurate measuring device. Here we have the exact opposite. So here we have both accurate and precision in our bullseye, our shooting. So if you're shooting at a target, your shooting here is accurate because you're shooting really close to the bullseye, and it's very precise. Precise meaning that you have a really tight cluster of shots. So if you have a tight cluster and it's close to the bullseye, then your shooting is precise and accurate. Okay, same thing with your data. So if these are data points, then the data points would be precise because there's very little difference in the data points that are taken, and they're all very close to the accurate, the actual true measure. In this one we have precision but not accurate. So here we have a cluster of shots here. So you have your very close packed shooting, very precise, but it's all far from the bullseye. So this would indicate probably that there's some sort of error in your device. So there's a systematic error in your device. So, and I'll talk about systematic and random error a little bit later. But here you have precision. The shots or the measurements are close to each other, but it's not accurate because it's very far from the bullseye, the true data set. Now here, this is an interesting situation where the data points are all very far from each other. So this is not precise data, or the shooting is not precise. And you might say that it's not accurate either, right? That might be a conclusion to come to. If we're looking at each individual data point, we would say, yeah, each individual data point is not accurate. However, if you take the data points together and you average them, right? So then you would find, I try to draw this, that they're like kind of equidistant from each other, the equidistant from the bullseye. So if you were to average the distance from the bullseye, you'd probably get a dot. The average dot would be right on the bullseye. Okay, so this would be an example of where the average data is very close to the actual number or the actual measure, and so it would still be accurate. And the reason you want to do averages is for the purpose of getting rid of what is called random error, where it just fluctuates randomly because of the nature of the measurement itself. You can't get rid of all error. There's just some errors inherent, and usually sometimes the measure is a little high, sometimes it's a little low, and so averaging will kind of equalize that and get rid of the highs and lows, and so the average should be closer to the actual value if you have accurate data. So here on the board I have 4 charts that kind of go along with the bullseye, but I wanted to use actual data. So you'll see that, let me bring this closer so you can see more clearly. Okay. And so here you'll see you have four sets of data. 4 students take data on the same things. So here, let's say you're trying to find the mass of an object and you're using a some sort of balance of some sort, or maybe you're using a another instrument. So you'll see here, like student A, you have the mass here. So these are 4 trials. So each student has 4 trials, and each time they measure the mass of the object. So the mass is 10.49, and then the second trial is 9.79, third trial 9.92, and so on. So the bar graph here is comparing the different trials, and so you can see visually that the difference in the measurements are actually quite a bit off. So here the data would be imprecise. But if you take the average of the data, you'll see that the average is fairly close, not on the line, but it's fairly close. The average here is 10.13, so it's a little inaccurate, but not as inaccurate as the individual points, except for maybe that one. That one's closer. But the average, you get rid of the fluctuation, and then this is where the average would lie. So here you might have not quite average, not quite accurate, definitely not precise. Okay. Here you have the situation where you see the data points of this student. The student measures, but he's consistently low compared to the mass of the actual mass, the true value. Um, but his individual measurements are pretty close to each other. So this would be an example of where you have precise data, but look at the average. The average is below the line. It's quite a bit below the line. So this would be inaccurate, but it's still precise. So this would be precise and inaccurate. This would be imprecise but accurate. I think we could say that that's accurate. Um, so that's these two here. Um, student student C has a situation where the student, again, look at the data points. The data points are really close to each other, so there's very little fluctuation between among the data points. So this would be precise data. And then if you take the average, you'll see that the average is accurate as well. And you can see that each of the individuals are fairly accurate as well. So here you'd have accurate and precise data. And then last but not least, here's the situation where you have imprecise data. So you got a lot of fluctuation. So there's imprecision in the data. But when you average them out, the average is accurate. So this would be accurate but imprecise. So in this situation, looks like you might have a systematic error. So this would be analogous of like if you're shooting an arrow or if you're shooting a gun and you're shooting at a bullseye and you are consistently off to the left or to the right or below. If you're consistently below, then maybe there's something with your sight on your gun that you have to fix, right? So there's a systematic error in your gun. Here, that would be related to this here. So here, if I have a tight cluster here, then that means that the instrument that I am shooting with, maybe it's a gun, maybe it's an arrow, a bow and arrow, but whatever it is, there's something wrong with my device. I need to fix if it's a gun, I got my front sight on the gun. I need to fix that because I'm shooting I'm shooting consistently high and to the right. So I gotta fix that. Same thing with your measuring device. So if something like this happens, it usually indicates some sort of error in the machine itself. So it has to be recalibrated or something like that. That would be for the device. Random error, this might be more like random error where you have fluctuations all over the place. So you would average that and get an average that's close to the bullseye. So that's what's showing here. So this is what precision and accuracy looks like when you're looking at data. Okay, so I hope that was helpful. I hope that clarifies when we're talking about accuracy and data, when we're talking accuracy and precision in data, we're referring to either how close the value is to the actual value, accuracy, or we're talking about how close the individual measurements are to each other, and that would be more related to precision. Okay, and the repeatability of the data. So when we talk about instruments being precise or imprecise, we're talking about how reliable or is the data that we can get from the instrument, or how repeatable is the data. So if I'm using an instrument and I'm getting, each time I measure using that instrument and I get a different value from the thing that I'm measuring, then that means that the instrument is going to be imprecise, and there's going to be I'm not going to be able to write down as many decimal places in my answer, if you remember what we talked about regarding significant figures. So I hope this was helpful. Next time I'll be talking more about random error and systematic error, so come back. If you like this video, please subscribe, hit the bell, comment if there's anything you want to know. Thank you very much.